In this module, we'll finally put transformers to work. You'll use Hugging Face to load powerful pre-trained models in just a few lines of Python. Run them on real text and get ready to fine-tune larger models later. You've already done the hard conceptual work, what transformers are and why attention matters. Now we'll turn that understanding into code with Hugging Face, loading real pre-trained models in a few lines, then fine-tuning them, and, later on, practicing how to prompt large language models effectively. Hugging Face is basically the operating system for modern NLP. Picture three pillars working together. First, the hub, a huge collection of pre-trained transformer models you can reuse instead of training from scratch. Second, the transformers library, a clean Python API that loads those models in only a few lines of code. Third, supporting tools like datasets and tokenizers, which give you a complete end-to-end workflow for real projects. Before running any transformer models, you need a stable playground. Start by deciding where you'll work, a local setup using Venv or Conda, or a cloud notebook like Colab or Kaggle. Next, make sure you have a recent Python, pip, and that you're comfortable running commands or cells. Then choose whether you'll run on CPU only, or use a GPU if you have one available. Finally, keep each project in its own isolated environment to avoid package conflicts. To get started, install the core Hugging Face stack with pip install transformers, and optionally add datasets and accelerate. In notebook environments like Colab, you'll often rerun these installs at the start of each session. After that, verify your GPU with a quick PyTorch check. Import torch, then run torch. CUDA.is available. If it returns false, that's fine. You can still follow along using smaller models on CPU. Execution will just be slower. The pipeline function is your shortcut from raw text to intelligent predictions. You choose a task name, like sentiment analysis or text generation, and pass in some text. Behind the scenes, Pipeline downloads a suitable pre-trained model, sets up the tokenizer, handles pre-processing, and formats the output for you. You don't have to worry about tensors or token IDs. It's the fastest way to go from "I've heard of transformers" to "I'm actually using one." Here's how little code you actually need. You import the pipeline function, create a sentiment analysis pipeline, and then call it with any sentence. It returns a label like positive or negative plus a confidence score. Then you can play. Feed it clearly positive text, clearly negative text, and more neutral or sarcastic lines, and notice where it starts to struggle. You're already getting real NLP value with almost no setup. Pipelines are a convenience wrapper. Underneath, two main pieces do the real work: the tokenizer and the model. The tokenizer, like auto-tokenizer, turns raw strings into token IDs, attention masks, and other tensors. The model, like AutoModel for sequence classification, consumes those tensors and produces logits or embeddings. By loading both with a hub ID, you gain control over pre-processing, can swap architectures, and can fine-tune models with much more flexibility. Tokenization is how we turn raw text into numbers a model can actually work with. Instead of whole words, modern models use subword pieces. So even rare or misspelled words can be broken into familiar chunks. The tokenizer always uses the same vocabulary and assigns each token a consistent integer ID. It can also insert special tokens to mark things like sentence boundaries or tasks. This explains why long inputs sometimes get truncated or split in ways that may surprise you. Once text is tokenized, the model no longer sees words, only numbers. Those numbers are the input IDs, each token mapped to an integer, arranged as sequences in a batch. Alongside them, the attention mask acts like a filter. Ones mark real tokens the model should pay attention to. Zeros mark padding that should be ignored. Most modern tokenizers build both for you, so you can pass clean, ready-to-use tensors directly into the transformer. Let's walk the sentence, "Transformers are amazing," through the pipeline. We start by adding a start token, killx, then split the words into subword tokens like transform, hashtag ag, airs, and amazing, and finally close with sep. Each token is replaced by a fixed ID, and the attention mask marks real tokens with 1 and padding with 0. To the model, this entire sentence is just these numbers and masks, never the raw text. Pre-training is like giving the model a long, unsupervised reading marathon. It reads books, articles, websites, and code, and is simply asked to predict missing or next words. By doing this at massive scale, it naturally picks up grammar, style, word associations, and a lot of general world facts. So when you load a pre-trained model from Hugging Face, you're starting from a broad, well-read generalist, not an empty shell. Fine-tuning is how we turn that general language model into a specialist. We begin with a pre-trained model that already understands language broadly. Then we attach a small task head, like a classification layer, and train on labeled examples for a specific job, such as sentiment or spam detection. Most of the model changes only slightly. Mainly the head and a few layers adapt. That makes training fast, data efficient, and ideal for building your own text classifier next. Transfer learning is the bridge between huge general models and your small specific project. Pre-training does the heavy lifting, massive data, lots of compute, broad language knowledge. Fine-tuning is the lightweight step, your dataset, your labels, your task. You're not starting from scratch, you're customizing a powerful base. Tools like Hugging Face hide much of the complexity, so even beginners can reach strong, production-ready results with limited resources. You've just moved from abstract transformer theory to working code. You set up your environment, installed transformers, and confirmed whether you have GPU support. You ran a pre-trained model with the pipeline API, saw tokenization produce input IDs and attention masks, and connected pre-training, fine-tuning, and transfer learning to your upcoming text classification and LLM prompting projects.